What's up, everyone? I'm Mr. Avila coming to you from Southern California, sporting a little UCLA today, my alma mater. Today, we're going to continue on with our series of videos on Pre Algebra. We're going to introduce to you what integers are. And if you're watching this video and you're not in my class, welcome. Today, you are one of my students. As always, make sure to have a paper and pencil as these lessons are interactive. You need to put in some work in order to understand this math. So let's get ready for our warm-up. In your warm-up, we're going to review what we did in the previous lesson. Please apply the order of operations in order to evaluate these algebraic expressions. First, do your substitution, and then use the order of operations to find their values. Good luck. Pause the video. When you've done all these, unpause, and then we'll move on when you are ready. All right, moving on in 3, 2, and 1. Answer number 1, 2. Answer number 2, 5. Answer number 3, 12. Answer number 4, 18. Answer number 5, 84. Answer number 6, 65. If you have any problems, try to reach out to me or make somebody that you're around watch these videos and have them learn with you, and you guys can figure out how to do these 6 problems. Okay, let's do a quick little review. What was the difference between what's on the left and what's on the right? On the left, we have expressions that have variables. On the right, we have expressions that don't have variables. On the left, we have expressions that are called algebraic expressions. And on the right, we have expressions that are called numeric expressions. Little quiz on vocabulary. Write this down just like this is. Write down the 5 words on the left and the 5 expressions on the right. And I want you to just draw arrows and match them up. Variable, what does it match up with? Algebraic equation, what does it match up with? Numeric expression, algebraic expression, and numeric equation. Match them all up as best as you can. Pause the video, and I'll show you the answers in just a second. Moving on in 3, 2, and 1. Again, you should have paused, wrote this down, draw arrows, match the words with their expression. Okay, here we go. Ready? Variable goes with M. Technically, it could have gone with another one, but that's the best one it goes with. Algebraic equation goes with that one. Numeric expression goes with the bottom one. Algebraic expression goes with the very top one. And numeric equation goes with that second one on the top right. Hope you were able to match them up and understand the difference now between those 5 vocabulary words. If not, look at the previous lessons as I defined them earlier. Good job. Today we're going to do numeric expressions with integers. So the important thing about this lesson is this idea of integers. It is seriously important. You're probably going to have to watch this lesson more than once because the basics of integers tend to be one of the most challenging things for students to understand and one of the most difficult things for teachers to teach. It took me about 10 years to get to a point where I felt I was able to explain this in a way for my students to understand. Hopefully you understand today's lesson. So in order to understand integers, first let's do a little review of I'm thinking of a number problem. I'm thinking of a number. So I have a number in my head. If you add 10 to my number, the result is 9. What number am I thinking of? Did you hear me right? I'm thinking of a number. If you add 10 to my number, the result is 9. What number could it be? That's the same as saying this. Some number, x, plus 10 is equal to 9. What number am I thinking of? Well, it turns out that that number is what we call a negative number. That is called -1. Okay, -1. So here, if I add -1 plus 10, I get 9. So here in mathematics, we created this new type of number that in a sense like cancels out a positive number. It's called integer. So let's talk about those numbers, the integers. The integers are the set of positive and negative whole numbers, and here they are. We're all very comfortable with the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, etc., etc., etc. The integers also include numbers that are below 0, -1, -2, -3, -4, -5, -6, -7, etc., etc., etc. Negative numbers is like if you have $5, the opposite of having $5 would be owing $5. So that would be -5. 5. So can you think of a number? Here's all our numbers here. That is a number, but it is not an integer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I get to 100, that's still an integer. 200, 1 million. Those are all integers. If I went in the negative directions, -1, -2, -3, -4, etc., 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 -10, -1 million, those are also integers. So what's a number that's a number, but it is not an integer? I'll give you a hint. Going back to this definition, it says the set of positive and negative whole numbers. In order for it to be an integer, they need to be a whole number. So can you think of a number that's not an integer? How about these numbers? Look at what those arrows dropped. Here and here. Those are not going to be whole numbers because they're in between whole numbers. For example, the number -3.8 would be a number, but not an integer. The number 1.5, it should be 2.5. The number 2.5 would be a number, but it's not an integer. So integers have to be positive or negative whole numbers. One of the important parts about dealing with integers is being able to put them in order from least to greatest. For example, if I give you these numbers, -3, 2, 6, and -10, if I asked you to put them in order from the smallest number to the biggest number, which one would be the smallest number? Think about it. -3, 2, 6, or -10. Which is the smallest? What do you think? Well, if we look carefully at our number line, the smallest number would actually be -10, because -10 would be first counting from left to right. So although it seems a little unusual that a number that's larger, like -10, is considered the smallest number, on the negative side, the more you go to the left, the smaller the numbers get. So -10 would be the smallest number, followed by -3, 2, and 6. So -10 would be somewhere over here, -3 here, 2, and 6. We're going in order from left to right when we write our numbers. What about these numbers? -5, 3, -7, and -2. Try it out first. Which would be the smallest number? And write these numbers in order from left to right. Here we go. Sorry, write these numbers in order from smallest to least to greatest. The smallest number would be -7. The next number, -5. The next number, -2. The next number, 3. Any positive number would always be greater than a negative number. Okay, I'm going to put up another set of numbers. You might want to try it first before I show you the answers. So write them down, put them in order from least to greatest, and then I'll let you know if you have it right or wrong. Okay, here we go. In 3, 2, and 1. First number, -12. Then -9. Then -1. We would have 0, 5, and finally 13. What do you think 0 is? Is 0 a positive or a negative number? Something to think about. Put these numbers in order from least to greatest. 43, -52, -10, 23, -1, and -27. Again, write them down. Write them in order. And we're moving on in 3, 2, and 1. The smallest number in this case would be -52, followed by -27, then -10, -1, 23, and 43. We've put these numbers in order from least to greatest. That's how these integers work. Okay, I'm going to ask you to try these on your own. Please order these numbers from smallest to largest. I wrote that they're in Spanish because I also have these videos in Spanish as well, but we were putting these numbers from least to greatest. Ordenen estos números de menor a mayor, from least to greatest. Write these down, put them in order, and here comes the answers. Moving on in 3, 2, and 1. Ready? And here they are. I'm not going to read them all out. Check your work. Make sure you have it right. Hope you did. And if you didn't, ask for help. Moving on to the next really important part of this lesson, that is adding and subtracting the integers. This is extremely important also. We know how to add and subtract using a number line. For example, if I want to add 2 plus 5, which we know is 7, well, I start at 2. I count 5 spaces to the right. 1, 2, 3, 4, 5, and I end up at 7. If I do 2 minus 5, well, start at 2, and I'm going to subtract 5. So I'm going to count 5 to the left. 1, 2, 3, 4, 5. That gives us -3. Nice. We're able to subtract 2 minus 5 and get a negative number. What do we get if we add negative 1 plus 1? So we start at negative 1 and we add 1 to it. Where do we get? 0. Well, this is interesting. Negative 1 plus 1 is 0, and we're going to use this idea. Negative 1 plus 1 is equal to 0 always. So we're going to use this idea to help us out with being able to do something like this. Negative 8 plus 6. Now, this is a way I teach to my students. There's many ways to teach adding and subtracting integers. This is a way that I found have been the most beneficial, so I hope you understand it. The way I'm going to represent negative 8 is I'm going to represent negative 8 with 8 negatives. 1, 2, 3, 4, 5, 6, 7, 8 negatives. That plus 6, I'm going to represent it with 6 positive symbols. 1, 2, 3, 4, 5, 6. As I mentioned earlier, negative 1 plus 1 gives us 0. So negative 1 plus 1, 0. Cancel them out. 0. Cancel them out. 0. Cancel them out until we have nothing left to cancel. What's left over? 2 negatives or positives. We're left with 2 negatives. So negative 8 plus 6 gives us negative 2. How about negative 4 plus 7? Write these down. You should write down the little symbols that pop up as well. Negative 4 plus 7. 6 and 7. So negative 4 I represented with 4 negatives. Positive 7 I represented with 7 positives. Cancel out the negative 1 plus 1 is 0. Negative 1 plus 1 is 0. Another 0, another 0. What's left over? I hope you see that we have 3 positives left. So negative 4 plus 7 is positive 3. You might have to write down these negatives and positives the first time you're doing these because it does take time to understand. Negative 6 minus 3. Negative 6, well, I see the 6 is negative, so I'm going to write up 6 negatives. You should do the same thing. Minus 3, well, since that 3 has a minus in front of it, I'm going to represent it with 3 minuses. Now here, there is no negative 1 plus 1. Nothing cancels. So I just count how many negatives do I have in total. 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 6 minus 3 is negative 9. Here are the rules so far for adding and subtracting integers. Please write them down. If the signs are the same, you add the numbers and keep the sign. If the signs are different, you subtract the numbers and use the sign of the larger number, and it'll help you to draw out the negatives and the positives as you get used to these rules. Write these down. I'm moving on. Take a minute to practice these using the strategies that I just shared with you. If you need to draw, like for example, that first one, 2 negatives, 3 positives, and then cancel out the zeros, the negative 1 plus 1s, and then see what you get. Okay, here are our answers. Ready? I hope you tried them. Try them first and then move on. That's how they're supposed to work. Don't just keep going on the video. Negative 2 plus 3, 1. Negative 3 plus 2, negative 1. Negative 4 minus 3, negative 7. Negative 5 plus 5, interesting, becomes 0. Negative 4 plus 6, positive 2. Negative 8 plus 3, negative 5. Negative 5 minus 1, here's the one where you just add all the negatives together, negative 6. And negative 10 plus 6 is negative 4. If you had trouble, rewatch these last couple minutes to look at how these rules get put together. It's not necessarily easy the first time you see this. Way to go, champs. Good job. Now, adding a negative and subtracting a negative is another aspect of this whole topic that gets also confusing. But if you read carefully what it says, then you'll be able to understand how to make the adjustments. Here we go. So let's say you have a brand new cell phone and you have your cell phone company is named Cell. Now you have $20 on you. You have your own 20 bucks. Now, to your situation, I am going to add a bill from the company Cell for $27. So I'm adding that you owe money to this company Cell. You have $20. You're going to add to yourself a bill that you owe $27. How much money do you have? If you had 20, but you got a bill for 27, how much money do you have? Well, we're going to look at it this way. You started with $20 and you added a negative 27 because that bill, it means that you owe money. So what are you going to have? Well, you're going to have the same thing as if you subtracted 20 minus 27, which gives you -7. I hope you had that figured out in your head. If you had $20 and you got a bill for $27, well, you still owed $7. So the answer is -7. The idea of this is that anytime you add a negative, it is equivalent to subtraction. So anytime you see 20 plus a -27, you can just change to a minus and proceed that way. Now, I have all kinds of money, so don't worry about your bill. Check out what's going to happen. You start with your $20, and since I'm such a nice guy, I am going to subtract your $27 bill. I'm going to take it away from you. Don't worry about it. Hopefully you realize that feels good, right? So you have your $20, and I'm subtracting the -27. That feels good. It's like I'm giving you money. Because whenever you subtract the negative, it's the same, it's equivalent to addition. So not only do you have your $20, but now it's like you got $27 more because you didn't have to pay that bill. So that's the same as having $47. The idea being, if ever you subtract a negative, that's equivalent to adding. So I read this 20 minus -27, that's equivalent to adding. So adding a negative is equivalent to subtracting, and subtracting a negative is equivalent to adding. That was confusing. We're going to show these rules in just a second. But before I show you those rules, try to see if you can use the 2 examples that I just showed you to find the answers for the following 8 numeric expressions. Pause the video, and when you're ready, unpause, and we'll see if you were able to understand what you've done so far. Moving on in 3, 2, and 1. Here are the answers. Number 1, 2. Number 2, 6. Number 3, -7. Number 4, -12. Number 5, 0. Number 6, -8. Number 7, -4. And number 8, 4. Congratulations if you were able to get those. If you were not, that's okay. This is not necessarily that easy. So I do want you guys to keep practicing these videos. And I'll post another video with more practice on these. Congratulations. So the rules are the following. I'd like for you to take a minute to write down all this so you can have all the rules in your head and go back and redo this video to make sure you understand all these problems. And then I'll try to post some more practice problems for you to do as well. Again, if you're confused, that's okay. Ask for help. Ask me, ask somebody around you, as yes, this topic can be pretty confusing. With that, that wraps up this lesson. Thank you so much for watching. I really appreciate you guys. If you have a question in one of your math classes and you'd like for me to put together a video, just let me know and I'll try to make one as soon as I can. With that, just want to say thanks again for watching this video. I'll see you in the next one. Bye.